Okay, question 6. In the diagram, segment ZA is tangent to circle C at point A and segment ZB is tangent at point B. Radii segment AC and segment BC are shown. Segment CZ is also drawn. Natalie must prove that point C lies on the angle bisector of angle AZB. Which of the following reasons are helpful for writing her proof? So this is just saying that this line right here cuts this angle in half. So that's what they're trying to prove. And again, I'm going to just be scanning through the proofs in the lessons to see if we have any. So on this it says we want to prove that segment CD bisects angle ADB. So this is very similar in drawing and in what we want to prove, because it's wanting to prove that point C lies on the angle bisector of angle AZB, which would be segment CZ. So this is very, very similar, and again I'm just going to scroll to the bottom. I'm not sure if you've noticed this, but I want to show you something. Reason 4 is blank in this, and if you scroll down, it has the reason filled in. So that's kind of an observation. I'm not sure if you guys noticed, but if you expand or click the show all button, it does show you the statements or reasons in the entire proof as you go through. So if you were stuck on like statement 4 and you were in show all, you could scroll to the one above it, you could see this one, and then you can go back and select it. So that's I guess an observation or a strategy you could use. So again, on this, the diagram's very similar. They drew in a lot of tick marks based off of what they proved. I would copy this down in my notes so I could use it again for the checkpoints. And what all I'm doing is I'm going to scan in the reasons and see if any of them are there. So I'm noticing reflexive property of congruence. It's not in this one. All radii of a circle are congruent. All radii of the same circle are congruent. If two segments are tangent to a circle and have the same endpoints in the exterior of the circle, then the segments are congruent. I'm not seeing that one here. I am seeing a side, side, side. It's not there. I'm seeing CP, CTC. And then definition of angle bisector. So now the one theorem that I'm not sure of is this side, side, side congruence, because they proved side, side, side. With this, if we know that these lines are tangent right here, that means they have a 90-degree. With a right triangle, there is what's called the hypotenuse leg congruence theorem, where you would only have to prove that their hypotenuse is the same, which it is right there, and that one of its legs is congruent to the other one, which it is because we have the radii right there, and all radii are congruent. So we would have the requirements for the hypotenuse leg congruence theorem. So that's another one that was raised as a flag, because right here they used the side, side, side congruence postulate, and I just noticed that they had the hypotenuse leg congruence theorem, which also has to deal with triangles, and we did know enough information to have that be helpful because we were given that those were tangent. Then we had a right triangle and we could use the hypotenuse leg congruence theorem.